Hi everyone, this is Dr. Nak, and today we're going to be learning about complex numbers. Complex numbers are often called by imaginary numbers because we get to take a square root of negative numbers now. Notice that before, we're told that we cannot take a square root of a negative number, such as maybe square root of negative 3. We will answer this as not a real number. But under the complex number system, square root of a negative 3 will be defined. Let's first go with the definition of an imaginary unit. The imaginary unit is defined by I, is the number whose square is negative 1. So the definition is I squared equals negative 1, or if you take the square root, I becomes square root of negative 1. Now, here's some properties of the imaginary numbers. So it says that if b is a positive number, then square root of negative b becomes a square root of b times the I. Do you see why that's true? Because look, if I have a square root of a negative b, it's not same thing as the square root of negative 1 times b. Well, using the property of the square root, you can split those up into the square root of negative 1 times the square root of b. But look at the definition above. What is square root of negative 1? Well, that's nothing but I. So that's why this becomes the square root of b times the I. Okay, let's do some examples. So please simplify square root of negative 25. Well, according to this rule, this is nothing but the square root of 25, and then square root of a negative becomes just an I. So here you're going to have square root of 25i, which becomes 5i. Let's take a look at another one, square root of negative 12. Well, let's first apply the property of imaginary unit. So here you're going to have square root of 12 times the I. Well, we're going to have to simplify all the way, so let's take a look. So 12 is 3 times 4. And then 2 times 2, so this is 2 squared times 3. All right, so this becomes square root of 2 squared times 3. And then I is outside of the radical. Since 2 squared is a perfect squared, what's going to happen is this becomes 2 square root of 3 times the I. And that's going to be the answer. All right, now let's go with the definition of complex number. A complex number is of the form a plus bi, where a and b are real numbers. So if you're given something of the form a plus bi, we called our a to be the real part, and we called b the imaginary part. And together it makes a complex number. Okay, let's take a look at example 2. Determine the real part and imaginary part of the following. 5 plus 2i. So, remember, all the imaginary numbers better have the form a plus bi, where a is the real part, and our b becomes the imaginary part. Alright, so in this case, which one is the real part? Well, I think 5 is the real part, and then 2 must be the imaginary part. So I'm going to answer that as real part is 5, and then imaginary to be positive 2. Let's do part B, negative 3i minus 4. Let's take a look at part B, negative 3i minus 4. Okay, so which one is the real part? Well, the real part is the number that does not have an I attached on it. So in this case, our real part is negative 4, and the imaginary part is going to be negative 3. So I'm just going to box that for the answer. let's look at negative 2i. Alright, so the imaginary part is the one that has an I attached on it, so clearly imaginary part is negative 2. But what the heck happened to the real part? Well, real part is quote-unquote missing, so that means that real part must be 0. Because look, we can write negative 2i as 0 minus 2i. So this is going to become the real part, and then negative 2 becomes the imaginary part. Part D, now let's just look at good old 7. Alright, so do we have any I there? Imaginary unit? No. So the coefficient on I must be 0. So the imaginary part is going to become 0, and the real part is going to be 7. Also, we can write this as 7 plus 0i. That's why 7 is the real part, and then 0 is going to be the imaginary part. Okay, I think we're ready to start adding two complex numbers together. So let's do it. So first example, let's add square root of negative 12 plus square root of negative 27. Well, first I see a negative inside of the square root. So I'm going to rewrite this as square root of 12 times the I plus the square root of 27 times the I. Okay, now we got to keep simplifying this. So let's break down the 12. We did this earlier, but this is what? 2 times 6, 2 times 3. So this is 2 squared times 3. And then our 27, it's going to be 3 times 9. 9 is 3. So we got 3 to the third. But since we're given the square root, I'm going to break this down to 3 squared times 3. Alright, now I'm going to rewrite the 12 as 2 squared times 3, and then I, plus the square root of 27 is 3 squared times 3, and then I. Now I'm going to circle the perfect one. So what's going to happen here is 2 square root of 3i plus 3 times the square root of 3i. And do we have like term here? I think so. We both have, these two terms have square root of 3i as a common factor, so I'm going to factor that out. And square root of 3 times the I, and then here you're going to have 2 plus 3. So here we're going to get 5 square root of 3i as our final answer. Let's do another one. Square root of negative 8 plus square root of negative 32. Feel free to pause the video and try this problem on your own. But meanwhile, I'm just going to work it. So first, I'm going to rewrite this as square root of 8i plus the square root of 32i. Then I'm going to break down our 8. 2 times 4. 2 times 2, so this is a 2 to the third, but I'm looking for perfect square. So I'm going to rewrite this as 2 squared times 2. Okay, and then let's take a look at 32. 4 times 8, 2, 2, 2, 4, and then 2, 2. So what do we got? We got 2 to the 1, 2, 3, 4, 5, 2 to the 5th. But I'm looking for perfect square, so I'm going to break it off at a 2 to the 4th times 2. Alright, I'm going to rewrite square root of 8 as 2 squared times 2. And then I plus square root of 32, 2 to the 4th times 2. And then I. Alright, so let me circle the perfect ones. I could simplify these under the square root. So this becomes... Thank you, Moku. 2 square root of 2 times I. And then plus, remember, square root of 2 to the 4th is same thing as the square root of 4 divided by 2, which gives us 2 squared. So this is going to be 4. So here we're going to have 4 times the square root of 2 and then I. Alright, so I think we can combine the like terms here. So the like terms are square root of 2i. So if I have to show all the steps, this is same thing as 2 plus 4 times the square root of 2i, which gives us 6 square root of 2 and then I at the end. Okay, now let's take a look at something a little bit different. Simplify 2 minus 5i minus 5 minus 2i. So we're basically subtracting two complex numbers from one another. This is not as bad as you think. So let me just start off with 2 minus 5i. Guess what we need to do next? Well, you're going to have to distribute that negative sign in. So here you're going to have negative 5 plus 2i. Alright, so from here, all you have to do is combine the real part and then imaginary parts together. So real part is 2 minus 5. So that will be negative 3. And the imaginary part is negative 5i plus 2i. So which gives us negative 3i. So that's going to be our answer. Let's just do another one. 3 minus 2i plus negative 5 minus 4i. So try this on your own and see if you can do this. And meanwhile, I'm going to start off with 3 minus 2i and then plus negative 5 minus 4i. And I'm going to rewrite this. And positive, negative in a row is going to make it a negative 5. And then here you're going to have minus the 4i. Alright, so let's do the same thing. Combining the real parts, we got 3 minus 5, which is minus 2. And imaginary part, we have negative 2i minus the 4i. So in this case, we're going to have negative 6i. And that's it. That's going to be the answer. Okay, now we're done with adding and subtracting complex numbers. Now, guess what's coming next? Yes, multiplying and dividing complex numbers now. Alright, so let's take a look at this example. Multiply 2i times 7 minus 5i. Okay, so all you have to do is apply the distributive property to this. So I'm going to distribute the 2i to each term. So here you're going to have 2i times 7, which is 14i. And then you're going to have 2 times negative 5i. So here you're going to have negative 10. And then notice that we're going to have 2 times negative 5 times I times I. So in this case, we're going to have I squared. Now from here, we're going to have to use our definition of the imaginary unit. Remember, what was I squared? It was negative 1. So what we need to do now is to replace I squared with negative 1. So we're going to get 14i minus 10 times negative 1, which gives us 14i and then plus 10. And we usually write complex number as real part first and then imaginary part next. So I'm just going to rewrite it as 10 plus 14i. And here's our answer. Now let's look at part B. 3 plus 2i times 4 minus 3i. So guess what we're going to do? Yes, we're going to FOIL this. So first, I'm going to go like this. Multiply the 3 to negative 3i, then here, and then here. Alright, so we got 3 times minus, oh, just kidding, 3 times 4 first, which is going to be 12. And then next one is going to be minus 3 times minus 3i. So here we're going to have negative 9i. And then inner term is 8i. And the last term is going to be minus 2 times 3 is 6. And then here you're going to have I squared. Now I'm going to use the definition of the imaginary unit. So here, let's just combine 12. And then let's combine these two together. So what we're going to get here is just a negative 1i. We'll just write it as negative I. And then minus 6 times I squared is negative 1. So here what we're going to get is 12 minus I and then plus 6. So now I'm going to combine the real parts together to get 18 and then minus I. So that's going to be our answer. Now let's look at something like 3 plus 2i whole quantity squared. Be careful, you cannot just distribute that exponent to 2 to 3 and then 2i off the bat. 3 plus 2i whole quantity squared means you gotta have to multiply 3 plus 2i twice. So here, write this out, 3 plus 2i times the 3 plus 2i. Okay, now from here, we're going to be doing the same thing as part B. We're going to be foiling this. So here what we're going to get is 3 times 3, 9, and then plus 6i, plus another 6i, and then plus 4i squared. Okay, so now I'm going to combine all the i's together to get 9 plus 12i, and then plus 4 times I squared is again negative 1. So what do we get? So we're going to have 9 plus 12i minus 4. So which is going to give us what? 5 plus 12i. And that's all we have to do. Okay, now let's take a look at something like square root of negative 36 times square root of negative 4. So take one step at a time. So first, I'm going to simplify square root of negative 36. So that becomes square root of 36 times the I. And then we're going to be multiplying here by the square root of negative 4, which becomes square root of 4 times the I. Remember, everything's being multiplied together. So here, let me see, square root of 36 is 6. So we got 6i. Multiplying here by square root of 4 is 2. And then we're going to have I here. So then here you're going to have 12i squared. Now again, we're going to be using the definition of I squared being negative 1. So here we're going to have 12 times negative 1, so our answer is going to be 12. Okay, so I'm trying to do all different kinds of multiplication involving complex numbers. So let's try something like this now. So we got 3 minus square root of negative 12, multiplying that by 5 plus square root of negative 27. Okay, so again, take one step at a time. So let's first rewrite this as 3 minus, okay, next we're going to simplify square root of negative 12. So here you're going to have square root of 12 times the I. All right, and the next complex number is going to be 5 plus square root of 27 times the I. As a side work, I'm going to simplify the square root of 12. So this is 12 is 2 squared times 3. And the 27 can be broken down into 3 times 9. 9 is 3 times 3. So here, this is going to be 3 to the third, but we're looking for perfect squared. So we're going to break down this into 3 squared times 3. Okay, so I'm going to do this step by step. So here, I'm going to rewrite the square root of 12 as square root of 2 squared times 3. And then I, parentheses closed. And then parentheses, 5 plus square root of 27 can be written as square root of 3 squared times 3. And then I, parenthesis closed. Okay, so I'm going to circle the perfect ones. Now, this becomes 3 minus 2 square root of 3i, parentheses closed, and then parentheses 5 plus 3 square root of 3, and then I. Now from here, we FOIL. We got this. So first term is going to be 15. And next term is going to be, let me see, 3 times 3 root 3i. So that's 9 square root of 3i. Now the inner term is going to be negative 10 square root of 3i. And the last term is going to be minus, what is that? 6. And when you multiply the square root of 3 times the square root of 3, that becomes 3. So here we're going to have 3, and then we're going to have I squared. So if you didn't catch the very last term, when you multiply the two last terms together, look at it this way. So we have, what is that? Minus 2 square root of 3i, and then you're just multiplying this guy by 3 square root of 3i, right? So then, remember, everything's being multiplied together. So I can rewrite this as negative 2 times 3 times root 3 times the root 3 times I times the I. Same thing. That's why I got negative 6, and then square root of 3 times square root of 3 gives us 3, and then we had I squared. That's how I got this guy right here. All right, so now let's keep going. So what do we got? So this is same thing as 15, and then we can combine plus 9 square root of 3i minus 10 square root of 3i. So that just becomes negative 1 square root of 3i. And then here, let's be careful here, we got negative 6 times 3, 18, I squared. By definition, that's negative 1. Okay, so what do we get? So looks like we're gonna have 15 minus square root of 3i, and then plus 18. And which becomes 15 plus 18, 33. 33 minus square root of 3i. And that's gonna be our answer. Before we do the next example, let's go with the definition of a complex conjugate pair. A complex conjugate pair is of the form a plus bi and then a minus bi. So for example, the conjugate, so let me write it as conjugate of maybe 3 plus 2i is 3 minus 2i. So basically, you're going to be changing the sign between the real part and an imaginary part. All right, so now I think we're ready to do this. So I'm going to call this one example, what now? Is it 4? All right, so now let's take a look at multiply 3 minus 2i times 3 plus 2i. Why not? So basically, we're multiplying the conjugate pairs together now. All right, so let's take a look. We're going to do the same thing. We're going to be foiling this. So first term is 3 times 3 is 9. Next one is 3 times 2i, which is 6i. And the inner term becomes negative 6i. And the last term is going to be negative 4 and then I squared. All right, so now if I combine the like term, notice that imaginary part is going to become 0. Basically, it's going to disappear. So here, I can write this as 9 minus 4i squared. But the I squared is negative 1. So here you're going to have 9 plus 4, which gives us 13 as the answer. Now notice that when you multiply two conjugates together, then imaginary part disappears. This always happens. Okay, so let's take a look at another one. Let's try negative 2 plus 5i and its conjugate, negative 2 minus 5i. Okay, so let's take a look. First, I'm going to multiply negative 2 times negative 2, that's 4. And then the next term is going to be plus 2 times 5i, so you're going to have 10i. And then inner term is minus 10i. And the last term is going to be negative 25i squared. So what we're left with is 4 minus 25i squared, which becomes a negative 1. So here you're going to have 4 plus 25, which is going to be 29. Now, if you want to think of it in this way, this is totally fine. So you guys remember, if we had a plus b and then a minus b, this is same thing as a squared minus the b squared, wasn't it? So we can apply that to multiplying two conjugates together, because look, if I have negative 2 plus 5i and then negative 2 minus 5i, all right, so who plays the role of a? Well, a is negative 2, and then our b is just 5i. So if I follow the difference of 2 squared formula, then here you're going to have negative 2 squared minus b squared, which is just 5i squared, which will give us positive 4 minus 25i squared. So you're still going to get 4 minus 25 times the negative 1. And here we go. We can get 29. So this is just a little shortcut way to do it, but feel free to use that. All right, so let's take a look at part C, 8 minus 2i multiplied by its conjugate, which is 8 plus 2i. Okay, so in this case, I'm going to apply that little shortcut, which will be the difference of two squares. So this is same thing as 8 squared minus b squared. Well, our b is just 2i. So here we're going to have 8 squared minus the quantity 2i squared. So here, this is going to be 8 times 8, 64, and then minus 4 times the I squared. So this is 64 minus 4 times the negative 1, which is 64 plus 4. So our answer is going to be 68. And you can check to make sure that your answer is correct by foiling the two terms together. All right, now we have added, subtracted, we multiplied complex numbers. Now it's time to divide them. Okay, so let's take a look at something like this. 4 plus 3i divided by 3 minus 4i. So, you know what? Don't do this. I used to do this. Oh my gosh. Maybe I shouldn't tell you because you might do it. But oh well. Okay, so I used to break that up into 4 over 3. And then minus 3i over 4i. No, do not be like me. That is the wrong way to go. So what is the correct way? Well, here's the trick. When you divide two complex numbers together, trick is to multiply top and bottom by top and bottom by the conjugate of the denominator. Okay, always. So this is just gonna be our trick. So here, let me just rewrite the problem. So let me just rewrite it as 4 plus 3i over 3 minus 4i. Okay, so what's the conjugate of 3 minus 4i? Well, that's 3 plus 4i, right? So what I'm going to do is multiply the top and the bottom by 3 plus 4i and then 3 plus 4i. Okay, now be careful. 3 minus 4i is one quantity. So make sure to put a parentheses here. And then also 4 plus 3i is also one quantity. So make sure to put parentheses there. Okay, so now let's take a look at the numerator. So this basically boils down to 4 plus 3i multiplying here by 3 plus 4i. And the denominator is going to be 3 minus 4i and then 3 plus 4i. So basically you're multiplying the two conjugates together. So for the numerator, I have no choice but to FOIL it. So here what we're going to get is 4 times 3, 12. And then plus 16i plus 9i plus 12i squared. Okay, whole thing divided by. Now I'm going to use the shortcut, which is the difference of two square method to multiply the two conjugate on the denominators together. So here what we're going to get is 3 squared minus 4i squared. Now if you don't want to do that, that's fine. Just FOIL it out and you're going to get the same answer anyways. Okay, so then let me just go over here. So we got 12 and then plus 25i plus 12i squared is negative 1. Whole thing divided by 9 minus 4 times 4, that's 16, and then I squared. All right, we can do this. So this is same thing as 12 plus 25i and then minus 12. Whole thing divided by 9 minus 16i squared is negative 1. All right, so then it looks like we're gonna have, well, 12 minus 12 is 0, so we have 25i divided by 9 plus 16, which gives us a 25i divided by 25. So that just becomes 1i, which is just an I. All that work to show that when you divide 4 plus 3i over 3 minus 4i, that was nothing but just cute little I in disguise. Okay, so let's try this one. Part B, 2 plus 5i divided by 5 minus 2i. So please pause the video and try this problem on your own. But meanwhile, I'm going to start. So I'm going to put parentheses around this, and then I'm going to multiply the top and the bottom by the conjugate of the denominator, which is 5 plus 2i. And let's get started. So this is same thing as 2 plus 5i, and then 5 plus 2i divided by 5 minus 2i times the 5 plus 2i. Okay, so now let's multiply the numerators together. So we have to FOIL, so we're gonna get 10 plus 4i plus 25i, and then plus 10i squared. Okay, now whole thing divided by 5 squared minus 2i squared. All right, we got this. So this is going to become 10 plus 29i, and then plus 10 times negative 1, whole thing over 25, and minus 4i squared. Again, I'm trying to do this step by step by step. Okay, so if you can do this by not doing it step by step, feel free to do so. But anyways, I'm going to keep going. So this is same thing as 10 plus 29i minus 10 all over 25 minus 4 times I squared is again negative 1. So from the numerator, 10 is going to cancel. So what do we got? We got, you know what, I'm going to run out of room. So let me just bring this guy over here. Okay, so now we got 29i, whole thing divided by 25 plus 4, which is going to give us 29i over 29. So again, our answer is going to be I. Okay, now let's take a look at something like this. We're still dividing. So example 6, divide 5 plus 3i divided by 4i. Okay, so we're going to do the same trick. We're going to multiply the top and the bottom by the conjugate of 4i. Can you guess what the conjugate of 4i is? It's negative 4i, by the way. Okay, so here I'm going to multiply here by negative 4i and then negative 4i. Do you see why that's true? All right, sorry. So remember, 4i is same thing as 0 plus 4i. So in this case, real part is 0, and then the imaginary part is 4. So the conjugate of 0 plus 4i is 0 minus 4i, which just becomes negative 4i. So that's how I got negative 4i to multiply on the top and the bottom. Okay, so now let's start. So if I rewrite this nicely, we have negative 4i. We're going to be distributing negative 4i to 5 plus 3i. And on the bottom denominator, we're going to have negative 16i squared. All right, we got this. So distribute. So we have negative 20i and then minus 12i squared. Whole thing divided by negative 16 times I squared is again negative 1. Okay, so this is going to be negative 20i minus 12 times I squared is again negative 1. Whole thing over positive 16. All right, we got to keep going. So this is negative 20i plus 12, whole thing dividing by 16. Okay, so now remember this. A plus B all over C. This is A plus C plus the B over C. Not A plus C, A over C plus the B over C. All right, so we're going to apply this and I'm going to split them up. So this is same thing as negative 20i over 16 plus 12 over 16. Okay, so now we're going to reduce this all the way. So what goes in? So 20 and 16, does 4 go in? I think so. 16 divided by 4 is 4. And then 20 divided by 4 is 5. So here what we're going to get is negative 5i over 4. And then plus, let's simplify, 4 goes in, right? So here, this is 4. And then this is going to become 3. So what we're going to get is plus 3 over 4. Okay, so now what we need to do is we're going to have to swap this because look, real part comes in the second here. So we're going to have to put the imaginary unit at the end. So we're going to swap this around and then we're going to write this as 3 over 4 and then minus 5 over 4 times the I. So that's going to be our answer. I know, you want to try another one, right? So let's take a look at part B, 2 plus 4i divided by 5i. So again, pause the video please and try this on your own. But meanwhile, I'm going to start. So the conjugate of 5i is negative 5i. So I'm going to multiply the top and the bottom by negative 5i. Now I'm going to distribute negative 5i to 2 plus 4i. So I'm not going to rewrite it this time. I'm just going to straight up distribute this. So we have negative 10i. And then what do we have? Minus 20i squared. Whole thing over negative 25i squared. So this becomes negative 10i minus 20 times I squared is negative 1. Whole thing over negative 25 times the negative 1. Let's keep going. So this becomes negative 10i plus 20, whole thing over positive 25. Okay, next step, what do we do? Split them up. So next one is going to be negative 10i over 25 and then plus 20 over 25. Okay, we can do this. So let's reduce the fraction. So what goes in? 5 goes into 10 twice, into 25 5 times. So we have negative 2i over 5, and then plus, looks like 4 over 5. All right, so now we're going to rewrite because we want the real part to appear first. So swap it around. So the real part is 4 over 5, and then minus 2 over 5, and then I. So this is our answer. Okay, now let's talk about powers of I. Okay, so let's find a pattern of this. So I'm going to start out with an I. All right, and then I'm going to go with I squared, I to the third, and then I to the fourth. Okay, so let me see. So I just stays as an I squared is -1 by definition. Now I to the third power, that's same thing as I squared times an I, isn't it? So here what we're going to get is -I, because I squared becomes -1. And then I to the fourth is nothing but I squared times the I squared, which is going to give us -1 times the -1, which becomes 1. So what do we got going on here? If I start out with an I, next one's going to be -1. Third is I to the fourth is 1. Now let's see what's going to happen if I raise I to the fifth power. Well, that's nothing but I to the fourth times the I. But the I to the fourth was 1. So we have 1 times I, which becomes an I. All right, now let's just keep going. We could do this all day long. All right, now let's go with I to the 6th, which is I to the 5 times the I. Well, I to the 5th, we just computed that. That's I. And then multiplying here by I. So we have I squared, which is -1. Do you see anything here? All right, so we got, let's look at from the top. We got I, -1, I, 1. And next term becomes I, -1. And what do you think I to the 7th going to be? Yes, I to the 7th is going to be -I. And I to the 8th is going to be just +1. Do you see the pattern? So if I raise I to certain power, it's going to repeat in a cycle of 4. It's always going to be either I, -1, I, and then 1. So our next topic is given I to the certain power. What is that going to equal to? Is it I, -1, I, or 1? So that's the game. So let's just start out with simplify I to the 86th power. Now I'm going to straight off the bat teach you how to do this by the shortcut. Okay, so notice that I repeats in a cycle of 4. So what we need to do is this. The faster way to do it is divide 86 by 4. All right, now what we want is the remainder. So you'll see what's going to happen in a minute. So here you're going to have 2 times 4, which is 8. Now drop down to 6. And then how many times 4 is going to go into 6? Once. And then 1 times 4 is 4. Remainder is 2. Okay, so what's going to happen is this. I to the 86 is going to equal to I to the its remainder after you divide 86 by 4. So it's going to be just I squared. Well, what's I squared? -1. Boom, we're done. So here it is. Okay, let's do another one. I to the 75. Okay, so we're going to do the same trick. I'm going to divide 75 by 4 and then look for its remainder. So how many times does 4 go into 7? Once. 35. And then 8. 32, and the remainder is 3. Remainder is 3. That's all we care about. So now we can write I to the 75th power as I to the third. Well, what's I to the third? That's nothing but I squared times the I, which is going to give us just the negative I for the answer. Now let's take a look at I to the 92nd power. So pause the video and try this on your own and see what you get. But meanwhile, I'm going to start. So again, since I repeats in a cycle of 4, I'm going to divide, oh, why did I put 94? It should be 92, sorry. And then divide this by 4. So 4 goes into 9 twice. Drop down the 2. And what? 3 goes in. So look at it. Remainder is 0 now. Okay? So let's follow the same procedure. So I to the 92nd power is same thing as I to the 0th power. Do you guys remember what that is? Anything to the 0th power, as long as base that's not equal to 0, that's nothing but 1. Because remember, if we have 2 to the 0, that was 1. 5 to the 0, that was 1. So I to the 0th power is just also going to be 1. So for this, our answer is just 1. Alright, I'm going to stop right here for this section. So if you have any questions at all, you know where to find me. And good job everyone, and I'll be talking to you soon.